All right, now we're going to do something a little different. Now we're going to talk about simplifying rational expressions. In the last section, we had monomials. They had one term. These, you have more than one term, okay? This is a binomial. Here you get binomials. We've got trinomials down here on F and H. So what you do first on this section is you're going to factor the top and the bottom if you can. So first thing when you factor, you say, do I have any common factors? So what does 3 and 27 have in common? They have 3 in common. What does x to the fourth and x to the third have in common? That'd be x to the third. So I'm going to take out 3x to the third. I'm going to write out to the left. What's 3 divided by 3? 1. And then 4 minus 3 would be 1x minus 27 divided by 3 is 9. Add 3 x's, took 3 out, so nothing's left. And that's divided by 6x. Okay, so there's your first step. Your next step is you're going to simplify the factors. So on top, I've got two factors. I've got this piece, 3x to the third, and I've got x minus 9. And I'm going to see, does 6x have anything in common with any of those factors? Well, you see it has something in common with this factor. So I'm going to simplify this. So 3 divided by 6 is 1/2. Okay. Add 3 x's on top, 1 x on bottom. So where do I have extra x's? I have extra 2 x's on top. I didn't put the 1 there. It's implied to be 1 because I'm going to have other terms up there, but you can put 1 if you want. So this will take, I could simplify this to 1/2 and then add 3 x's on top, 1 on bottom, so 2 extra on top. And then I also have this x minus 9. So this is going to be your answer. Okay, also we have to find the restricted values. So restricted means the bottom cannot equal 0. So restricted, I'm going to write this up here. Restricted, this means the bottom cannot equal 0. So I'm going to look at the original bottom. So 6x. 6x cannot equal 0. Okay, divide by 6, divide by 6. X cannot equal 0. So those are my restricted values. Okay, so that's the restricted values. Reason why is if x was 0, then it'd make the bottom 0 and it'd make it undefined, which we can't have, okay? Let's go look at the next one. So the first thing you do is any common factors. So what's 2x squared and 18x have in common? 2 and 18 have 2 in common. X squared and x, they each have x in common. Okay, and so I have 2x. I took out 2x out of there. X squared divided by x is x. 18 divided by 2 is 9. Had an x, took it out, so I'm left with that. On the bottom, was x squared and 9x have in common? Well, they have x in common. So if I have 2 x's, I take 1 out, 1's left. If I have 9x and take out x, what's left? 9. Okay, so there's the first step of factoring there. Now I'm going to see, do I have any common factors? So you see the top and the bottom, both are being multiplied by x, so they both have a common factor of x. So I'm going to cancel out x. They also both have an x plus 9 as a factor, so I'm going to cancel that out, and I'm just left with 2. Now let's look at restricted. So restricted, so I'm going to have x times x plus 9 cannot equal 0. Okay, so remember, this is, even though it canceled, we'll talk about this later, it'll still create a hole in the graph. So this is factored form, so I'm going to set each factor equal to 0. So x cannot equal 0, that's already solved. And x plus 9 cannot equal 0. Subtract 9, x cannot equal 0 and negative 9. Okay. Let's go look at f. So I've got x squared minus 3x minus 18 on top, and x squared minus x minus 30. We could play the whole factoring game. If there's any common factors besides 1, no. But we can play the whole what multiplies to this and adds to this. So what multiplies to negative 18 and adds negative 3? What about negative 6 and positive 3? Okay. On bottom, what multiplies to negative 30 and adds to negative 1? So what multiplies to negative 30 and adds to negative 1? What about negative 6, positive 5? Negative 6 times 5 is negative 30. Negative 6 plus 5 is negative 1. Okay. Do I have any common factors? I have x minus 6 in common, so I'm going to take that out of here. I'm going to be left with x plus 3 divided by x plus 5. And that's going to be my answer. I can't cancel these x's out because they're not factors. They're not multiplying with the entire quantity on the top and the bottom. Now, restricted values, remember, the bottom cannot equal 0, so x minus 6 times x plus 5 cannot equal 0. So I'm going to set each one equal to 0. Remember, the slash of the equals just means it cannot equal. Add 6, x cannot equal 6. Subtract 5, x cannot equal -5. So these are my restricted values, -5 and 6. All right, let's look at h. So on h, man, on this one, it's not 1x squared, and I can't, there's no common factor. So what I'm going to have to do here is I'm going to do the either guess and check, or I'm going to have to do the box method. So I'm going to have to find two numbers. I'm going to write this over here. Might be a mistake. Actually, let's write this down here because I have more room to show my work. So 3x goes in one, x in the other. They're going to be the same. They're both going to be pluses. So let's look at 8. 8's 8 and 1 or 4 and 2. I think it's going to be 4 and 2 like this. Let me prove why I'm right. 4 times x is 4x. 3x times 2 is 6x, and that adds to 10x. So that's good. So 3x plus 4, x plus 2. Now x squared minus 4, that's a difference of two squares. Difference because it's subtracting, and x squared and 4 are both perfect squares. So it'll be x plus 2, x minus 2. And on this one, do I have any common factors on the top and the bottom? Any common binomials? I'll have x plus 2. So that cancels, and I'm left with 3x plus 4 divided by x minus 2. Now restricted values, the bottom cannot equal 0. So I'll need to find x plus 2 times x minus 2 cannot equal 0. I'm going to set each one equal to 0. Subtract 2, x can't be -2. Add 2, x can't be 2. So x can't be -2 and 2.